Well, tonight we want to talk about this subject that life, the life that you and I have, the life that is in existence in this world, is so complex that mere chance processes, even over billions of years, cannot explain its origin. Tonight we want to look at proteins. How did they begin? All of the theories are nice and simple, but they don't fit the facts. Living matter is composed largely of proteins, which are long chains of amino acids. Now, you know, I don't know what I'm talking about here. Sounds like amino acids, but amino is just what they call them. Since 1930, however, it has been known that amino acids cannot link together if oxygen is present. We were actually talking about this earlier, but focusing on it tonight. That is, proteins could not have evolved from chance chemical reactions if the atmosphere contained oxygen. Well, when did it not? You see, the chemistry of the Earth's rocks, both on land and below ancient seas, shows that the Earth had oxygen before the earliest fossils formed. We do not know of a time, archaeological time, where there was not evidence of oxygen. An authoritative study, Philip Morrison, Earth's Earliest Biosphere, in Scientific American in 1984, fairly recent times, concluded that the early biosphere, life, what's surrounding life, contained oxygen before the earliest fossils, bacteria, formed. I think the earliest life was bacteria. Iron oxides were found that imply a source of oxygen enough to convert into insoluble, not dissolvable, ferric material, iron material, the ferrous solutions that must have first formed the flat, continuous, horizontal layers that can in some sites be traced over hundreds of kilometers. So he's saying that there is evidence of oxygen enough to oxidize, turn soluble iron into insoluble, to make it, to deposit it on the layers. So that simply means in earliest times that they can find, oxygen was there. Definitely stating, as they've known since 1930, that no life could be formed while oxygen was present. Eric Dimroth and Michael M. Kimberly, writing Precambrian Atmosphere Oxygen, Evidence in the Sedimentary Distributions of Carbon, Sulfur, Uranium, and Iron. Catchy little title. This in the Canadian Journal of Earth Sciences. They said, in general, we find no evidence in the sedimentary distribution of carbon, sulfur, uranium, or iron that an oxygen-free atmosphere has existed at any time during the span of geological history, recorded in well-preserved sedimentary rocks. Wherever they look, whenever they look, they find oxygen. Philip Abelson, Chemical Events on the Primitive Earth, his article in Proceedings of the National Academy of Sciences. This is where the top guys get together and discuss stuff and write it out. What is the evidence for a primitive methane ammonia atmosphere on Earth instead of oxygen? The answer is that there is no evidence for it, but much against it. And he put that emphasis there in the original. Even earlier, solar radiation from the sun would have broken water vapor into oxygen and hydrogen. That's what makes up H2O, hydrogen 2 and oxygen. So the radiation would have broken that down into the oxygen and hydrogen. So some hydrogen, because it's the lightest of all the elements, would have then at the top of the atmosphere escaped into outer space and just filtered away, leaving a heavy oxygen behind. So this, when nothing was living, or at least in their opinion. Okay, another difficulty arises. That's one, oxygen. It can't come together, accident even on purpose, if oxygen is present. To put it together, to check this out, they have to remove the oxygen. The second one, another difficulty arises because to form proteins, amino acids must also be highly concentrated in an extremely pure liquid. So they can do this today, you see. Get rid of the oxygen, but the amino acids have to be concentrated, that's, lots of them, in an extremely pure liquid. Contaminants will destroy the amino acids. Francis Crick, now I'm going to emphasize him here for a bit. He wrote Life Itself in 1981. He says, it is difficult to imagine how a little pond with just these components and no others, no contaminants, could have formed on the primitive earth. Nor is it easy to see exactly how the precursors would have arisen. What would have led up to an extremely pure, concentrated pool of amino acids? How does that evolve? That's his question. Now, he's a well-known scientist, and we'll get more into him because what he's talking about here, he's pushing a theory that he has that I think all of us are going to laugh about. But that's the idea. How could that have come about? Such an extremely pure pool of amino acids couldn't have existed. In the day-to-day life of primitive Earth, the early oceans or ponds would have been far from pure and would have diluted amino acids. It would not be concentrated and it would not be pure. So the required collisions between amino acids would rarely occur. They have to be concentrated so that many of these occur because only some of them connect and only some of them make the chain of protein. Jack Travers and David Abel, chance and necessity do not explain the origin of life. In their book, Cell Biology International, volume 28, he said, but when multiple biopolymers must all converge at the same place, at the same time, to collectively interact in a controlled biochemical cooperative manner, this is a lot of, all these things had to happen. It says, faith in self-organization becomes blind belief. No empirical data, no evidence that you can actually show in a lab, empirical data or rational scientific basis exists for such a metaphysical leap. They said, well, it just happened. Well, that's pretty strong belief in your science, and that's the only way it works. Besides, amino acids do not naturally link up to form proteins. This is really a third point here. This doesn't happen naturally. And of course, in the beginning, evolution is doing it just by itself. Happens just happens. But they don't naturally do this. Naturally, proteins tend to break down into amino acids. Are you familiar with the second law of thermodynamics? Enough to tell me what it basically means?
Energy is lost, things break down.
Yes, in every transfer of energy, energy is lost. So generally, everything is breaking down. That's what happens. That's the way things are. That's why it's called a law of thermodynamics, the second law. First law is that energy is conserved. The sum total of energy is not lost, but the process transferring energy from dynamo to wires to all these other things, there's a loss of energy along the way. So, George Wald, Origin of Life, Scientific American, back in 1954, he says, I believe this, the second law of thermodynamics, that things are breaking down. The natural way is that things break down. This, the overwhelming tendency for chemical reactions to move in the direction opposite to that required for the evolution of life, to be the most stubborn problem that confronts us. The weakest link at present in our argument, talking about the origin of life, accidental origin of life. All the pressure around is that it breaks down, not comes together. Furthermore, the proposed energy sources for forming proteins. So you have this pool, and somehow, magically, it's a concentrated pool of amino acids, and it accidentally has become purified. And it's there. Now, it's just laying there, so it needs some energy, some spark, something to energize it and bring it all together, make it into life, you see. So, what do they propose? Well, the proposed energy sources for forming proteins: Earth's heat, electrical discharges, or solar radiation. In fact, each one of these destroy the protein products. The thing they have to call upon to make it are the things that destroys it. They destroy it thousands of times faster than they could have formed. D.E. hold thermodynamics, first and second laws of thermodynamics. Thermodynamics and kinetics of spontaneous generation. That's what evolution is, spontaneous generation. The conclusion from these arguments presents the most serious obstacle, if indeed it is not fatal, doesn't end the theory, to the theory of spontaneous generation. First, thermodynamic calculations predict vanishingly small concentrations of even the simplest organic compounds. Secondly, the reactions that are invoked to synthesize, the reaction, the heat, the electricity, whatever, that are invoked to synthesize such compounds are seen to be much more effective in decomposing them. The scientist says, the very things we say made it are the things that destroy it. The many, you see, multiply that then by billions of years. This is happening over and over and over again, see. The many attempts to show how life might have arisen on Earth have instead shown A, the futility of that effort, B, the immense complexity of even the simplest life. Darwin talked about simple life forms, like you just trip over it and it would come to life. And now you look at it with the electron microscope and you find these things are incredibly complex. And C, the need for a vast intelligence to precede life. There has to be some intelligent design, some ability to put this together. So we come back now to Francis Crick. He says in that same book, page 88, an honest man armed with all the knowledge available to us now could only state that in some sense the origin of life appears at the moment to be almost a miracle. You can hear him struggling to try to get that out. So many are the conditions that would have to have been satisfied to get it going. People have talked about if all these things are dials, you'd have to set each one at precisely the right number before all of this could happen. Who is setting those dials? How did it just happen that all of them were there? Now, Francis Crick, he's a Nobel Prize winner and the co-discoverer of the DNA molecule. So the guy is no slouch in science, you see. He did not give up. Miracles? No, I don't want a miracle. He reasoned that if life could not have evolved on Earth, which he thinks he's proved, it must have evolved somewhere else in our galaxy and been transported to Earth. Well, this is an old theory called panspermia, seed, spermia, everywhere. Just how life evolved on a distant planet is never explained. Somehow that solves his problem. It happened someplace else, and we don't know about that. Then Crick proposed directed panspermia, that an advanced civilization sent bacteria to Earth. So the little green men gathered around whatever they call a table and planned it out. Let's inject life in the petri dish of planet Earth. So he recognized that it is difficult to see how viable spores could have arrived here after such a long journey in space, undamaged by radiation. At his level of understanding, he thought that would be difficult, but maybe not impossible. He mistakenly thought that a spacecraft might protect the bacteria from cosmic radiation. Crick grossly underestimated the problem, and you can see in Eugene Parker's article, Shielding Space Travelers, that it's a very difficult thing being out in space for a long time. The experiments by Harold Urey and Stanley Miller, we're changing subjects a bit here, are often mentioned as showing that the building blocks of life can be produced in the laboratory. But not mentioned are the misleading claims. They had an experiment where they were able to produce the building blocks of life in this, but even that is misleading. So let me give you a list. Organic is life type of molecules in life are of two types. There are proteins, which we're talking about, but then there's also the nucleic acids, which are DNA and RNA. Now, nucleic acids, which contain vast amounts of incredibly complex information, were not produced, nor would any knowledgeable person expect them to be produced. How would they produce in the laboratory and inject all this information in a chemical language in these molecules? It's just beyond comprehension. Then, secondly, the protein building blocks were merely the simpler amino acids. Of all the simple ones, these were the simplest. The more complex amino acids have never been produced in the factory, in the laboratory. 2011, several more amino acids were found in their old experimental materials, but the more complex amino acids found in life were still missing. So they came back and they were all, yahoo, we found more amino acids that he built, and he didn't know it at the time, or they didn't know it. And that's recorded in the Eric Parker's Primordial Synthesis of Amines and Amino Acids in the 1958 Miller experiment. All right, then, most products of these chemical reactions are poisonous to life. So it sounds like, oh, we can see how it happened here, but what they produced, if it was mixed with other life, would kill the other life. The amino acids are as far from a living cell as bricks are from the Empire State Building. You're talking about the most elementary building blocks. Then half the amino acids produced have the wrong handedness. If you read about this, think of a hand in a mitten, so sort of shaped like this. And so that they can be this way or this way. So they call it left hand, right hand. And for life to exist, it has to be the correct handedness for a position. So what they found they produced in these basic elemental things were the wrong one. It wouldn't have worked to create life. And then Urey and Miller's experiments contained a reducing atmosphere, which the early Earth did not have, and components such as a trap. In this case, the word trap does not exist in nature. A trap quickly removes chemical products from the destructive energy sources that make the products. So the energy to do it is going to kill them, and then so the trap gives the energy and then takes it out. But there would be no waiting trap to do that at the beginning. So all of this above shows why intelligence and design are necessary to produce even the simplest components of life. Michael Behe in Darwin's Black Box, a book that I highly recommend, it's quite interesting to read, in a thing called, his chapter called Molecular Machines, talking about how complex the simple life forms are. He says this: the story of the slow paralysis of research on life's origin is quite interesting, but it would take too long to talk about it here. The space precludes its retelling here. He says this: as time passes, eager people researching the origin of life have dropped away because it's nonsense. It doesn't work. They can't make any progress at it. So the slow paralysis of research on life's origin is quite interesting, but we don't want to get into it. Suffice it to say that at present, the field of origin of life studies has dissolved in a cacophony. You know what a symphony is, where all the phony, the sounds are harmonious. Cacophony is bad sounds. So this is the tuning up of the orchestra, and even worse. A cacophony, so these studies have dissolved into a cacophony of conflicting models, each unconvincing, each seriously incomplete, and each incompatible with the competing models. So I went this, and I went that, and I say this, and I say this, and none of the two could fit together, and none of any of them are compelling. He says, in private, and here's my last statement, this is Behe. In private, even most evolutionary biologists will admit that science has no explanation for the beginning of life. And why? Because they refuse to believe that God created. That's it. That's all they have. We have to go with us, even though it's ridiculous, because otherwise we'd be believing in God and creation. Choose not to believe.